Number 8, the shoreline runs north and south. So here, this is the shoreline, north and south. And a boat due east, over here, of the shoreline. The bearings of the boat from the 2 points are 110 degrees and 100. So remember, bearing means going from north. All right, assume the 2 points are 550 feet apart. How far is the boat from the shore? All right, so this is a 90 degree from here because this is going east from this point there. That would be east, but these are off. And we have this distance. So question is, we want to know how far is the boat from the shore. We want to know this distance here. This is an x, so it works great that I'll put an x because it's going left and right. How could I find it? Well, let's start with this. If we know this is 100 degrees, we could find out this angle because every straight line makes 180. So I know this is 80 degrees there. That's a 90. This one has to be a 10-degree angle. Just the same, this is 100 and 10 up here. This would be 70. And again, this is another 10-degree angle. So how could I solve this? Well, if I want to solve this distance, I have to have a length to work with, which right now on this triangle here, I don't have any single lengths. So what I'm going to first do is focus on this triangle right here. And I'm going to say, okay, can I find a length on this one that is shared with the bottom triangle? The truth is, yes, I can. I could find this length right there. So how do I do it? I will use the law of sines because I have a completed set. I would say sine of 10 degrees over 550 will equal sine, we want this length there, so the angle across from it is 70, sine of 70 over, and for the, let's just call this an h, because on this triangle this will become an h, so we'll call that an h right there. H. Now we could cross multiply and divide. I'm just going to use InSolve real quick so we can see what's happening here. I'll go calculator. So menu 3-1, menu 3-1. You would cross multiply and divide if you want to do the algebra. And so we have sine of 10 degrees over 550 equals, fraction here, sine of 70 degrees.
It is the end of the school day. Students should go
Over our h. Like that. So when I solve, I get 2976.31. And so this h right there, we just discovered, and that's an ugly looking h, so I'm going to kind of rewrite it here. I'll put h again. That h is 2976.31, and this would be feet. So now that I know this h, could I find this x? Yes, you could use law signs again for this triangle because I have a completed set. I have this side and this side, and so, or you could use side y cosec tangent is y over x and solve for your unknown. I'll show you that in a second. What I will do here is I'll just do law of sines because since I InSolve, the reason I did that is I'm just going to copy it and change for this one. Now that I know this h, it's across from 90, and so I could say that sine of 90 degrees over my h value that I just solved for equals sine of my 80 degrees is across from x, 80 degrees over x. And so I'm not going to type in the letter h there. I'm going to substitute. So first copy this down, and we know this is 90 degrees over, and this needs to be the answer here. So I can hit Control and this gives me this answer right there. And that here it's going to be 80 degrees. Come on, backspace, 80 over x. And this is how I'll get the x. And so it just told me the x equals 2931.09. I'm going to round this to the nearest foot, and so x would equal 2,936.1 feet. Now I'm going to prove to you we could do it the second way here, the second triangle. Once we knew our h, we could have used psi y cos x tangent is y over x. I'm given an h. I want to find the x. That means I want x on top of h. That's cosine. I could have also said, so let me draw a little line here. I could have also said that I have cosine of, you'd use the 10-degree angle, equals your x over that h value. And again, the h we know was that 2976.31. And so to solve that, I would multiply it across over here. And so I'll come back and I'll do it this way. I'm going to take the h, and I would multiply that times cosine of 10 degrees. And that gives me exactly the same value. So if you did it this way, again, 2976.31 cosine of 10 degrees would equal your x. You could do it that way when you multiply across. What I'm doing here, and I'll show you without having to write the big number again, is I'm multiplying by h on both sides. That's what I did. And so this does give us the same answer that way as well.